So welcome everybody to the June 29th Food Process Ontology Work Group. And we've got today is at least a two-part discussion. And the first part is about following up with some work that Kai and Tarini did to convert our tentative upper level material process by objective and mechanism hierarchy into OWL. And so I'll let them take away on that. And then Troy would like to follow in the second part with a deep dive on one or two food processes or material processes. So without further ado, over to you, Kai or Tarini. I'm not sure who wants to lead that part.
Tarini, if you want to say a few words first, I'm happy to show whenever you're
Yeah,
ready.
yeah, it's fine. I think we could just show what we've done. And then
I have to say this is work that Tarini and Damien did. I just compiled the robot template in the hopes that it would inspire further discussion and actually trying to place some of the food transformation process subclasses under the hierarchy that Damien and Tarini had created to be the new FoodOn process hierarchy. Yeah, so all that being said, I'm just going to go ahead and share. So within FoodOn at the moment, so we have currently the food transformation process, which looks a bit like this. There's kind of a very simple hierarchy with just a few super classes, not super well structured in relation to the other hierarchy, which Tarini and Damien had produced. So I'm going to go ahead and just open that one that we have now compiled. And this is what Damien and Tarini had been working on. So you can see here's like what the process hierarchy would look like. So under process, plan process, and then there would be kind of a couple main classes here, material processing by mechanism, process by mechanism, and process by objective. And then each of these will kind of expand out a little bit. So I'm like going through this a little quickly, but I'm just kind of expanding out to show what the hierarchy all looks like as Damien and Tarini had made it. So just like in contrast, just really briefly, that in contrast to this, you can see that there's a lot more thought out upper levels. But if you look at the existing one, there's a lot more subclasses as they currently exist within FoodOn when you drill down. So I think it would be really great to be able to place portions of that hierarchy under here. And so I was wondering if it might be a useful exercise today if we chose a couple of classes from this hierarchy, the current food transformation process hierarchy, for example, food cooking or harvesting, a few of these packaging, perhaps we could pick one, and then try to see where it might fit under this new hierarchy. But maybe before we do that, just briefly, if Tarini or Damien, if you wanted to maybe explain a bit about this hierarchy and kind of just roughly walk us through it, or if that's not helpful, I don't know. I think that might be a little bit helpful if we just very briefly, high level explain, some of the top level classes, perhaps some of these ones here, for example, under material processing or under my mechanism. I know that Tarini was speaking roughly about this yesterday, but maybe just a quick refresher if that's helpful for everyone.
Yeah, in fact, Magali's question. So what this upper level so far doesn't have is any equivalency reasoning or any reasoning at the moment. So Magali asked, why is material processing by mechanism not under material processing? And it would be inferred to go under process by mechanism. if we had the reasoner turned on and the equivalencies put in there, but we don't at the moment. And the reason why there's a process by mechanism or by objective is because processes don't always apply just to material things. They can also be like digital, more abstract representations that aren't material, but data. That's why there's this process by mechanism and objective. Now, you're asking me, process by mechanism, how can that apply to a non-material thing? Well, I was thinking of software algorithms that manipulate data from one thing to another, one form to another. But wasn't my interest, could be other people's interest to actually pursue those data-oriented mechanism and objective distinction. Okay, so maybe what else in terms of material processing? We have this other distinction about also about whether food processes kick in at some level, or whether we can just speak about the processes irrespective of food. And that's going to take some finessing, because food processing, the moment you mention food in particular, it's perhaps because of food safety or the characteristics of food that are particular. So all of that would slowly be built out in axioms that would justify why we have a food process by objective separate from all these other things like fractionation. But I mean, Tarini and I spoke to this upper level hierarchy. We just laid it out, but we didn't grill each top level category. Like, did we miss something under material processing by mechanism in those 5 upper levels? Is there something else that we missed there? And are those good names? So one could do a little bit of a breadthways critique of each thing and its name. So I did send out in that email about today, I did send out one glimpse at how Obi's handling one of those things right now, separating material. I believe Obi has a material separation class, which is exactly the same thing as this. So we might show a name or rename on this just to keep it Obi synced. But as well, that email mentioned, and this is my only comment, it mentioned that each of these things, each of these processes can actually have a, right, each of these can actually have a function and a device and an objective. So that's indeed what Obi has for this material separation, material component separation class. They have a separation objective, separation function, and a device. And you may ask, why all of that stuff? And that was their version of plug and play, which is what we're also trying to do here. So we may not get around to defining functions and the devices, like a mere hierarchy of those things. But for every mechanism, there is a function, basically, that is expected. And that gets into the business of describing what is a function. And so very briefly, it's something that resides in a device or mechanism. I mean, a material device of some kind.
Yeah, I would just add there, because you mentioned it, Damien, and I was thinking about it, looking at some of the classes we have, that you know, in our mechanism, it's very simply like energy, for instance, like it could be heat energy. But then there is like equipment, so it's an oven, or like if you have heat by radiation, and then you've got direction of the heat, which happens in an oven being a closed chamber. So many things, and then you've got dry heat and wet heat. So then you've got like not just equipment, but like something more about the environment as well, like the presence of moisture. So I think like what we've done is at the simplest level, it's just the energy input, something like that. Although separation is I mean, it's something else. It's not so energy, but it's the most basic definition. So, and actually, while I say this, I don't have a clear idea that when you start distinguishing this, adding equipment, adding environment, and I don't want to throw too many random thoughts, but I just want to complete that there are many aspects. So for instance, one of the classes is like shallow frying. I mean, it was written as pan frying, but then I changed it. So again, when you've got like the environment being oil in this case, like the quantity of it is another process. So these distinctions can get extremely granular, and I don't have a good system to handle that yet.
Yeah, yeah. What we can say is we could park actually modeling what a device is with respect to some process to some future session. What is an oven as a device, as
Right.
something with a function?
Hasn't Obi kind of done that to a certain extent too?
We've done it a little bit. Yeah, we've talked about objectives, but we haven't really talked about like as Trini mentioned, how do you talk about a device that has a certain humidity in its chamber and that's enabling certain kind of cooking and modeling.
Yeah, it's a little more complicated for sure than just processes that are being applied to food.
Right. So if everybody's okay, we'll just stick to the process side and we'll just put aside the function, the device for later.
Right. And just one more thing, because it can get very confusing. There's this colloquialism in food, and I don't know that there is any reasoning for this at all. So maybe we had synonyms, like we deal with it in some way, but I feel at a certain point, we can't reason. For instance, with nuts or seeds, you could call them being roasted or toasted. And, like there's like, and so there's, I think that at some point we cannot force a definition because these words have been in use for so long. So we have to find a way maybe to deal with it. But I'm saying maybe it's beyond reasoning.
It is beyond reasoning. And so the Global Foundry ontology approach is always to try to make sure the label is just long enough to capture a distinction that may not be so clear in natural language use. Even if it's a bit awkward in the label front, and we'll throw in the synonym on the natural language side.
But on the other hand, they could also be both subclass to the same high-level term. So I'm guessing something along something along the lines of like heating of material, like roasting and toasting could maybe both go there, for example. Perhaps, maybe I'm misunderstanding, but maybe there's a better place. But that's kind of what I was hoping to be able to discuss as some examples of trying to actually place some of the examples under here.
Yeah, another quickie. I was reading a recipe last night. British blitzing. Never heard that term before. It's now part of it, has to go into our food process. It turns out that's a quick blend, a quick mash of things in your blender, just really quick. Anyway, okay. So more to say, people, feedback. What are we missing? What names don't you like? For example. Okay, Magali. You get to please speak up.
Yes, I would say that just as Kai mentioned, I think, if I understood correctly, that you can have different kind of heating. It can be any thermal treatment, I guess. I don't know what you mean by heating. It is you bring some calories to you some heat calories, but it can be any thermal treatment such as roasting, for example, just as you mentioned. Is that correct?
According to this definition, any energy modulation in which thermal energy is applied to its material or environment.
Okay.
So here's a question, Magali. In the food world, thermal treatment means adding heat to something. Is that right?
Yes, I think so.
Well,
I would say so, but your definition is clear with adding energy, adding
Mhm.
adding heat, adding thermal energy is similar.
I think, okay, this is getting, a little bit too geeky, but a material could be heated without applying a heat source. For instance, if you apply like pressure, that could increase the temperature of the material, but you're applying pressure. And sorry to like, I don't know.
No, like the state.
Drop this
But
in here now.
Yes, but now the parent, currently the parent is energy modulation. So
right,
it could be by pressure, as you mentioned, but it is not in your hierarchy so far.
Well, like force modulation is closer to what you're saying, right, Tarini?
Exactly. Yes. So I'm wondering whether what is happening to the material, should we deal with this now? Could it, if we do, and I just bring this up because what if we invest this effort and then we realize that what's happening to the material could be different from, the energy, whatever is being input into the material.
But I think you have to specify thermal energy and the physical energy. If you mean pressure is different, you have to specify that your energy modulation is only about thermal energy, because there do exist different forms of energy.
Okay.
Yeah, that's okay. I'm talking about something else, about like what is being input into the material and then what's happening. So heating of material can happen. And there we're talking about the mechanism. So the mechanism to say it is energy is okay. Now, I mean, whether pressure is force or energy, I mean, I don't know. I don't have that knowledge to like really make that distinction. But all I was saying there is that clear what I'm saying? Like what's happening to the material is different from what's being supplied to the material. That's all.
I'm not clear about that.
No,
So
I'm not.
force versus
Like
pressure.
my basic understanding of first year physics would be like P is like force over area, right? Something like that, I think, is the formula.
Mhm.
What is your definition for for force modulation? You say a mechanism in which force is applied, but you are defining force by force. it is
Right.
circular definition, I think.
Well, I think no, I don't think that's fair. I think that force there is like the physics definition of force, and then here we're saying we're applying force to a material.
True, except there's a hole in this particular one, and Troy, we'll get to you in just a sec, but I just realized, so force modulation, the word modulation means we're allowing an increase or a decrease. And so vacuum sealing something is decreasing the atmospheric pressure, for example, but we've just said force is applied,
Yes, you don't want to say
only the increase. So we need to say force is modulated somehow.
Well, here you said applied or removed, so you could
That's
maybe
right. So or removed. Right. So we need that on the force modulation side too. Oh, right. We need that under force modulation. Right. Or removed from. Applied to or removed from.
Yeah.
Great. Okay.
So,
now the question, I mean, let's go back to that other the hierarchy. So energy, if energy is also, is it, right, I see, Tarini, you're saying energy is the input, but force isn't necessarily an input of energy. Maybe it is always in a minor way, but
so good force modulation. So energy modulation might have the thermal aspect and then cooling heat. No, that's interesting. So if force could generate heat. So like, for instance, if you imagine that you're cutting like a cube of ice or something, like if you place a razor edge on it, it'll start cutting through. And what's happening is you're applying force, but force by unit area, what Kai was saying is like turns into pressure. Also, I think what Warren said, Robert, sorry. And then, so I'm wondering if, it seems to me, I don't know how exactly to now create a hierarchy, but force should go under energy.
Right.
That's great point.
Because force implies some kind of mechanical energy.
That's
right.
True as the device, but the behind scenes in the device itself. So the process is using energy for sure, but is the material actually gaining energy as a result, or having energy removed from it? That's this. There's this distinction here.
But since we did material process, if we did processing by mechanism, then no, but because it's material processing, then I think like whatever is being applied is that it is in context of what is happening to the material.
Okay. Rather than what energy is required in the processes to affect whatever change.
Yeah.
Yeah. Okay. So that would suggest that force shouldn't be under energy modulation per se, because the energy here we're talking about is into the material. But one thing I think the next question for me is whether energy modulation should really be thermal energy modulation. Just to be clear, we should change that name.
Right. And actually, if we call it thermal energy, then we don't have that confusion, like where does force modulation go? If you just specify very specific thermal energy, then heat and cooling makes sense.
That's what I want. That is what I was suggesting, I think. But yes, I agree with thermal energy. It will be clearer.
Right. Okay. Yeah.
Good.
So one consensus. Yes.
So am I changing this? Cool. In thermal energy modulation
in half an hour? This is like
great.
Because Joseph Kai Stalin is leading the call. That's why. All right. Shall we change this to thermal energy modulation then?
Oh, right. Well,
right.
Definitely the name. Yeah. And then the question is, does it have a parent term? Like, is there anything but thermal energy modulation?
Well, yeah, there's force, and we have that. I mean, if you look at a high level here, what we now have is the big actions are cooking, whacking, mixing, and chopping, right? If I just like look at this at a very high level, and doing some stuff chemically, you know, the molecular, and that's great. Like this passes the sniff test, I would say, for the 95% solution. There are going to be some unusual processes like pressure cooking that are actually weird combinations of these things. But I think it's great what we've got right now, this sort of high level combining, separating force and thermal energy.
Okay.
Okay, so anyone against renaming energy to thermal energy? Going once. Going twice.
I don't know where cooking, just to be sure. At the moment
Magali,
we don't think about cooking. We are
sorry, Magali. I was
eating. It is not the same thing.
Sorry, Magali. I was using very sloppy colloquial terms just to make a general point. Right? That if you go to the average person out there and you say, what's involved with cooking? They're gonna describe stirring things, cutting things, putting things in an oven, putting things in a refrigerator, right? I mean, those are the big actions. And I just wanted to check that those big actions have a home here, and they do. That's my only point.
Okay.
Okay, so are there any other comments about the upper levels here? Glaring renamings needed. Putting them up.
Am I gonna go ahead and change thermal energy for now?
Yep.
Yeah, that makes sense. Yeah.
Fantastic. All right, and we had heating and cooling are both subclass to thermal. Fantastic. Okay, I haven't refreshed this page so that the change isn't going to show up here yet, but okay, so we have force modulation, thermal energy modulation, combining material, like this could also be like material combination or whatever, it doesn't matter really. molecular mechanism and separating. So I think separating and combining, that's pretty obvious. What do we mean by molecular mechanism? I see we don't have a definition.
That's the question I will say.
Okay, what do we
Yeah,
have as children? By
I
reaction
think-
type and by spatial location.
Yeah, so I think that in this, and this was this was sort of an issue, or like it was always an issue, but we didn't address it at that point.
Yeah.
So molecular mechanism is when you want to, it's sort of that distinction between what's happening at the macro level and the molecular level. So for instance, if you talk about like Maillard reaction, at a macro level, it's just that you're supplying like heat, and there needs to be some protein and sugar, but whatever, but you're supplying heat. And at the molecular mechanism, that's when what are the exact reactions that are happening in the Maillard reaction. So, and like you need this because when you really want to talk about what's happening to food, at least in food science now, the emphasis is always at the molecular level. So there's a macro and a molecular, and how to organize that. I mean, we could all stare at it and collectively come up with something, but that was like that was already an existing question.
But I guess if you mention there is a molecular mechanism, you mean that the other are all macro level mechanism? Because I understand perfectly why you have this need to distinguish between molecular or not molecular, but I think it is a matter of scale of observation. So
yeah,
I was just asking why we don't specify that there is molecular or macro level. There is it is at the same level. Is that a problem or not? I don't know, but it is just my question.
Could be. I mean, maybe let's just do that now and then see as we go further if that gets disrupted.
Mm-hmm.
So basically we would have a like macro level mechanism that would have everything else.
Yes, that's
right. And we could call a macro as something that's happening to the whole bulk of the material. Whereas molecular could be where it's like the specific changes, the specific like physical or chemical changes. And so
I think a molecular mechanism is at the scale of the molecule. It is clear for me, but I don't know what you mean by bulk mechanism, because for me, bulk mechanism is at the food level, the whole matter.
Right.
I don't know how to say that. So it is a macro scale for me, bulk mechanism. I don't know if you are right.
No. So actually, you're right there. But I mean, the word bulk I think it's used in both ways. Bulk is a reference to the whole thing, but there are some molecular behavior like gelatinization or swelling. And the reason it is bulk is because it's talking about like specific like biopolymers, which in the case of gelatinization is starch or something. So there you are talking about what's happening to the starch, but you're not measuring this one starch molecule. You're measuring the interaction of all starch molecules together. And that's why it's called bulk.
But I think because it is a kind of physical change, physical state change. It is at the bulk level, you have a physical state change, a change in the physical state, I mean, where because gelatinization is kind of physical, it's kind of transition between two states.
Well, so I think that has to do a little bit with the reaction. Yeah, so I guess there it is. There is a non-covalent reaction, and those would be like physical reactions. And anytime there's a physical reaction, it is possibly non-permanent, right? So that's why you call it a transition, because you can have gelatinization and you can go in the reverse direction. It's never fully reversible though, but I mean, you can go backwards because it was physical. So actually the chemicals are still there in their form, but you've changed the conformation.
Okay, hold on. Can I interject?
Yeah, let's let someone else talk a little bit.
I don't think we need to worry about I mean, I think we can name some phenomena as reversible
Yeah.
or not, but we don't need to have that as a key organizational point here.
No, no,
I
no,
think
not
so.
at all.
What I would
should
suggest,
we should not, because it is the context. It is depending on.
Right.
We can't
Can
say that it is.
for you food
I was-
scientist specialist people, can you tell me if what we're first searching for here is just a term that captures that a chemical reaction has happened in the food, as opposed to, say, a cutting, which isn't really a chemical reaction per se?
Mhm.
Is that the distinction that we're looking at? Because the chemical reaction, I get it. The chemical reaction can happen on the frontier, on a surface, or can happen throughout the material. But is it that molecular mechanism really means chemical reaction? Or is that too primitive?
Well, what about these ones? Like these are the other subclasses. Like, is this a chemical reaction? I don't think so.
For me,
It can be.
next step. For me,
It could-
when you to answer just quickly to Damien, for me, when you say molecular mechanism, it is a chemical reaction anyway.
Okay, so
it is at the molecule level. Then
I
Tarini
think
say you speak about
physical.
covalent, but but there is any chemical reaction. You don't need to have a covalent bound to have a chemical reaction. I don't know if it's what you were saying. Perhaps I misunderstood.
Yeah, you don't need a covalent bond, but then is it a reaction? So like hydrogen bonding is not a reaction.
But it can be a chemical modification if you prefer.
No, it's an interaction. It's not like there's a charge and that causes an attraction or a repulsion, and that gives you sort of surfactants or emulsifiers. They're all based on interaction.
So we may speak about we may have a reaction or interaction, I think. But
yeah,
but molecular or surface mechanism, it's not at the same level as molecular mechanism.
I don't know. I mean, we can talk about this. I'm happy to talk about, like, because this is, it's not, and at the time we did this work, like, it was to consult someone in extreme detail. So I read like a few books about this just to see, like, what is a non-covalent, because interaction could be like, van der Waals forces, electrostatic forces, there are so many. And so non-covalent in some books just seemed to be, it is consistent with saying covalent and non-covalent. So in that sense, like if you just look at that class, you feel like you've addressed maybe all possible subclasses. Whereas if you say interaction, then you might have to specify. So it seemed like that was a good 2 subclasses that seemed to complete what was possible. And maybe then covalent reaction could be other types of, like, van der Waals. I don't know if it's interaction. We can talk about.
Van der Waals are interactions. There are electrostatic interactions.
Right. So then that would be like is non-covalent the same as saying interaction? But then it seems like, I think, but is it wrong to call it non-covalent? Like, why is it more accurate to call it interaction? I mean, I don't know if you should park this for now and maybe address the macro, micro.
Let Troy speak up. He's been waiting to talk for a while.
Yes, sorry, the point was not between, just to I think we are not discussing about the same thing. I'm not discussing about covalent or not covalent. I was just talking about bulk molecular mechanism and surface mechanism. For me, it's not at the right places now, but it is just to precise. Just Troy, you want to add something?
Let's park that for a second and let Troy comment.
Hi guys. I think what I'd like to do, if it's good for you guys, is draw our attention back to some of these other major classes and push us to drill them deeper. Because I think what there are other branches to be added to this tree for sure. At the same time, I think we need to extend some of the existing branches into their sub branches, and especially things like combining material, energy modulation, thermal energy modulation, separating material, these ones where we know the majority of the cooking action happens. Yeah. If I may, Damien, I would love to introduce some of my thinking on this subject. I think it'll be nice and complementary to what we've just been discussing.
Yeah, sure. And I'll just say,
Could we
I'll set up
address
I'll
the
set up an
macro
issue.
micro question before we get to that? I mean, it seems like that's still hanging.
Oh, it's definitely hanging. And what I was just going to say is I'm going to set up an issue on FoodOn where we need to hash out in words, I think, a bit more of this. I'll set it up as how to define molecular mechanism. And then we can drill down there on that issue. But I agree, it's this particular topic, especially with us, the rest of us trying to learn what you food scientists are distinguishing on, could be a little bit problematic to let's do a first pass as an issue, and we'll see where we all can get to. Okay. All
Okay,
right.
so Troy, you're proposing that we try to find some more examples of combining materials, or to create some more subclasses of combining material?
I'm proposing to present for the next 15 minutes. I have some things.
Okay.
I have stuff to say here.
Okay, I'm trying to be fair with everyone's time. 15 minutes is a lot for one speaker. So maybe if there's a short version that you could do, maybe like 5 minutes.
The original plan here, Kai, was that you get half this meeting and I get half, and I've been patient.
Okay. All right, in that case, turning it over to you.
Thank you. And like I said, it's in the same spirit here. Let me pull up this slides here, and I'm hoping this will be helpful. When we, as we've been talking about this, we've been saying that within this general domain of processing, we've talked about process by objective, process by mechanism, and within process by mechanism, there are these major groups that we were just talking about, right? And one of those, for example, was material separation. This is the sort of, cut and chop area of things. And Kai, I think one of the things you've been encouraging us to do is to somehow find a way to take terms like these things at the bottom. This is also in the same spirit as what we did a couple of weeks ago together, and find a way to build a bridge. Like, how do these things belong in that, somewhere in that upper level hierarchy, right? And like, there's some sort of connection there. There will be, right? Because all of these things, or a lot of these things, we can think of them as material separation of some form. But the question is, what are the intermediate classes between that thing way up high called separation of materials, or as I'm sort of labeling here, level 1, or at least, you can define, argue about where we are in space, and level N way down at the bottom. And that's what I wanted to try taking a stab at. In other words, as we're sort of drilling the tunnel or building the bridge top down from the discussion we just said, can we also be building it bottom up, or from the middle somehow, to make some combinations? Let me just pause there. Kai, I think this is also in the spirit of what USDA needs, right?
Yeah, I mean, in theory, I'm just trying to improve this. I'm just trying to get people to work together. That's it.
Cool. So this is what I took a stab at. And so what I'd like to do today is present some draft intermediate level classes, which exist somewhere between material separation up high, all the cutting stuff, and individual terms that people use and industries use and so forth for various specific kinds of cutting. One kind of cutting is fractionation. Material separation is fractionation, breaking something into pieces. And, this is things like chopping or grating cheese or crushing up some nuts or whatever. Yeah. And this is maybe the part we might think of first. If you were to ask someone, what is material separation? Or you might talk about breaking something up into bits. And if we think about it from a food, from the perspective of the physics of what's happening to the food, in essence, what's happening here is we're increasing the granularity of the thing, making it into smaller pieces in order to decrease the surface area because we want to do something with it. We want to spread it. We want to cook it faster, whatever. But there are other kinds of separation that are not fractionation. And so this is the first thing I'd like to introduce here is some additional terms, some additional sort of groups of things that are not fractionation, but they're still separation. One, for example, is sorting, where we take something and we're not actually breaking it into smaller pieces. We're just literally pulling them apart into parts that are different, right? With sifting, for example, we sort of run things through a grate so that the big things stay and the small things go. So that they're all the same kind of material, but they're of different size. Or grading, right? We might have nuts going down a conveyor belt, and someone may be pulling out the ones that are extra brown, for example. So these kinds of things, we're not sort of breaking it into smaller pieces. We're just dividing things. But what's notable here is that at the end result, what you've got is two different sets of things which are different in some way. Whereas these things, they're the same chemically or physically. They're just now they're in a smaller size. I'll add a couple more and then I'll just pause here for reactions. Then there's a separation where we're literally just taking something away. And so what defines this process is what you're left with, or sorry, what you've taken away. And a lot of times when we use words like peeling or shelling something or skimming, the term implies that something is gone afterward. It implies that something is left afterward. But the process by the definition of that process may not specify what happens to the thing that's gone. The point is it's gone now. And by the way, like this sort of removal process for liquids tends to have different terms associated with it than if you're doing it with solids. And then I'll do one more, displacement. So another thing we can do with separation is we can literally just move a piece of it to somewhere else. We didn't change it. We just like put the cheese slices into different sides of the tray, for example. Or we poured liquid from one place to another. If I pour off a little bit, technically I've separated the poured part from the part that's still in the vat, but I haven't really changed it. It's still the same liquid. It's just that the location of some portion of it is different. Or if I scooped it, or I arranged it, or I wiped something off a counter. And so my first sort of suggestion, draft for discussion, is that material separation has these 4 primary subclasses within it, of which one of them is the thing that we might have normally thought about under material separation, but there's an important 3 other ones. Let me just pause there, see what you guys, just sort of initial reactions to that.
Right. So what's going on, Troy, is you've just listed off 3 objectives of the processes: to displace something, to remove something, to sort something. So this launches us into a discussion of what's mechanism actually that's doing the sorting or the objective of sorting or removal or displacement. And is it that one could move those 3 things over, or fractionation too, if the objective is to reach a certain granularity, over to the process by objective side, and then multi-home these things like pouring, scooping, etc., and find out what their quote narrow blinkered mechanistic appearance would be. That's my first thought or reaction.
Mm-hmm. Damien, I continue to get confused about what the objective, what that idea of an objective is, because for me these are physical processes. It's not an intention; it's a result. Like the thing is moved or the thing is divided. Of course, one could say it was my goal to divide it, or I can say it is an outcome. It got divided. To me, that sounds like splitting hairs. I'm having a hard time understanding the difference.
Well,
but I hear you that it's important, so I'm keen to dig in with it with you and try and understand that distinction a little bit better.
Right. So sorting Yeah, it probably shows up where a process, a device or process can achieve different objectives and therefore support the functionality that approaches different objectives. But we are no longer saying that we're now saying that the mechanism is one step removed from any particular objective it's classified under. That might be the easiest way. So then I would have to go look for examples of that.
I'm definitely trying to be device agnostic here, or not to use device as a thing. So I didn't say, for example, knife processes and blender processes, for example. And let's take sifting as an example. Yeah, one could do this with by shaking something over a grate. One could do this by pushing something through holes. But the idea being that what you're left with, the result, is the same physical material, but with two different defined characteristics in two different places. And that to me is a physical description, which then would help us with inferences. If I've sifted something, then the two things that got sifted must be different in some defined way. That's something like that.
I think to me, why, like, all this makes sense. There's many ways in which you can think about this, but the reason this classification doesn't work is because it's not consistent. And by consistent, like, for instance, like, I'll take the fractionation because there's a little more thought process. It's like all the subclasses. Now, you could throw what there is and replace it. That's fine. But the reason it's consistent is because it's talking, all the subclasses are talking about some property of the material. You are separating because if there's a boundary inherent in an anatomical boundary in the material, or because of a physical property, like separating milk from cream is like density, or like a chemical separation, like Magali said, extraction. So like, for instance, a chemical separation could have to do with solubility, things that are water soluble or fat soluble. That's a way of separating. So that subclassification of fractionation is consistent. All the classes have to do with a material property. And in what you're doing here, for instance, is like, you could explain, maybe there is a consistency and it's hard to really see that. But so all this makes sense. It just seems very inconsistent. And because of that, as you go lower in this hierarchy, you could come up with, like, it might be a bit confusing.
Tarini, that's helpful. Could you give me an example of something here that doesn't quite work?
Well, so I haven't put thought into this, right? To immediately be able to give you a well thought out answer takes some time, and I cannot just give it to you now. Like, I'm happy to, but I need some thought. So if we look at fractionation, because there I have a clear example to give you, and then you could suggest something else, right? So, okay, sorry, material separation is fractionation. So for fractionation, or material separation, I would talk about what is the property of the material. So you separate by anatomical boundary. So peeling, shelling, deboning are all boundaries. Sifting, grading, centrifugation are material properties, the size of the particle, the density. Filtering, skimming can also be the same thing. Evaporation, it's also by material property. And the fact that you're removing what you're taking out, is it a solid, is it a liquid, is it a gaseous form of a liquid? That's sort of another, that's another layer, like what is gone and what are you left with completely depends on, the context. And like displacements, if I talk about material property, the fact that you move something from one location to another, you could displace things. It has nothing to do with, like, separation. That's like by context. So I'm not saying that what you've written here isn't right. I'm just saying that there's no consistency in the subclasses.
Might be consistency by objective, but in terms of mechanism, maybe not a consistency.
So just what I was suggesting is that we can consider that physical versus chemical separations could be two different mechanisms. And I think here we are more speaking about some objectives in your diagram, Troy. I think.
Yeah,
but it is not so clear to, but I agree that there is some discussion to have about your distinction here, because some comment in the chat was also mentioning that it was not clear for everybody that what is the difference between removal and some kind of sorting, I don't know. Or as far as I am concerned, I don't know if a displacement, for example, is a material separation, because it depends really on the example you are given. And so, as Tarini mentioned, it is context dependent, I think. I don't know how to say it's better, because
let me I'm gonna just show one more level of detail here, just to put a few more things on the table, and then I'd like to just come back to this general comment about objectives and sort of appropriate categorization of things in terms of sort of, so we have a step to do to where to go next. I want to what I was trying to do here, as you can see, was somehow get from these terms up to this term, while only paying attention to what is physically happening. And what I found is, by the way, this is also with consultation of several food science dictionaries and a couple of food scientists that I engaged with. What I found is it gets real meta and real tricky fast. Yeah. What really is the difference between, you know, like, is pouring, is that material separation or not? These are all very good questions. I did try digging a little bit deeper on fractionation specifically, so I wanted to show one way this could look. Yeah, and if you thought the last page was crazy, you're going to think this page is even more crazy. But I'm gonna stick it on the table anyways. With fractionation, sometimes we have what you might think of as partial fractionation, like stretching some dough. Like, is that separation? You're making some air pockets in it. You are ripping it, yeah, but you haven't exactly pulled it apart entirely into multiple pieces. So I don't know if that's fractionation or not. I've called it here partial dislocation. But of course, the more common version that we think about is when you've actually broken something into pieces. And there's things like chopping and dicing and so forth that we think of. But these, we could think about dislocation or breaking things into pieces in very different ways. One way is making something into smaller pieces, like I just said. And there, the defining factor is how small is the piece. If I really want to understand the difference between chopping and dicing and mincing, it is the same kind of motion, just done to differing degrees. And so you would need some metadata in these things to define grain size afterward, if you wanted to have a working definition that distinguishes chopping from dicing, for example. But grating something is a different action from chopping, right? Chopping, you're breaking into small pieces. Grating, what you're actually doing is you're running something through a hole. In some sense, then, the definition of it is a two-dimensional. It's the size of the hole you run it through that is the defining feature. We would not usually say that, but if you get right down to the physics, this is about the three-dimensional size you're left with. This is about the two-dimensional hole you push it through. Whereas slicing is actually defined by one dimension, the thickness of the slice. All of these terms, fundamentally, the difference between them is what you're applying it to and how thick is the slice. And then, of course, you could break something up without really having a definition as to what the size or shape should be. Like, I'm just going to smash these things. And that its definition, as distinct from these things, is we aren't specifying the three-dimensional or the two-dimensional or the one-dimensional. So at the risk of we're going right up to the limit here, this is what I just wanted to put on the table. Obviously, there's a lot more discussion need to have. This may actually create more questions than it answers, and that's good, I think. But this is the kind of abstract thinking I think it takes to somehow build a bridge from these things up to this thing.
I would say
that's a lot.
Yeah, sure. An interesting maybe perspective on this is, what do we have to tell a robot to do? And
yes, exactly. That was kind of the way I was trying to think about it. What action are you telling a robot to do?
So at the fundamental level, consider how many of those things are accomplished by the severing of a blade. And now we put a blade in a robot's hand, and now we tell them what to do.
Yes.
So the
yes,
first
exactly.
part of what we can tell them what to do in terms of mechanism is to chop. But then we haven't told them when to stop. So we got that. So we called that the mechanism part. But if we're now adding sensors to say when they finish the task, then that's this process by objective distinction that we've raised. But you're making an interesting point. So like, how do we compare grating to chopping? Something done with the blade versus something done with this other device that has these cleaved little blades in it, designed in a certain way to do something. So I would say one other thing I'll add is the form of the output thing. Is that actually the objective, to create a form of cheese that's slivered in a certain way? And whether we're doing that by laser, by knife, or by grater is possibly leading to the same outcome. It's just that we're using a different device to get there. So let's consider that we're studying objective outcome of the form of the material.
Yes, and of course, all these things, like, it's very hard to define what grading is without talking about a grater. Yeah. So one would almost always have a device called grater that is part of doing grading. The question is, what is the act of grading specifically, right? Obviously, it's using a grater, but that's circular logic. What are you doing using the grater to do? Yeah. And can you do it with a knife? Can you grate something with a knife? No, you can't actually. It's not grading.
Actually, you pretty much can if you're after a certain objective, but we wouldn't choose that method because this other method in this tool is already designed for the same outcome. So that's where you have to be careful, Troy. And,
yes. And so I guess my proposal for us is that we take one little tiny bit of what I did was already a tiny bit, right? It was just within material separation, but we maybe even need to take a smaller bit. For example, chop versus grate, literally those two terms, and see, can we somehow locate chop and grate professionally, appropriately in our taxonomy? Yeah, I think that's like the really tactical exercise for us. And what I've shown is honestly, like just how many different paths it may take, and I guess how much work it's going to take to get it done.
Yeah, I agree. Okay. And we are, as you say, we should be answering these use cases in the real world and not making it incredibly complicated for people to comprehend, like BFO.
Yeah, exactly. Because at the end of the day, we need a FoodOn or Obo ID for grading.
Yeah.
And it needs to make sense to people who grade things.
Mm-hmm. So
right?
We're just going to have poly hierarchies here. So we're going to have grading from one particular sense, and you will get to there from a fairly conventional understanding. That's my hope. I think the way you'll get there is through objective. Whereas that's our intuitive, developed over hundreds of years cooking technology thing where we just go to that place. But the creative robotics, replace process A with B because it achieves the same objective, will be a different turn, a different hierarchic organization that won't be that familiar to people or will seem a bit more awkward. I don't want to stick that in front of people's face, except that if we're to answer more than just the conventional chef approach to this, we would find ourselves making distinctions over there.
Like, for example, Damien, is this where you would be placed, like fractionation by form objective? Is that saying like we're trying to like fractionate by some structure that's being achieved?
Right. And
so
then
in that case,
make up your mind which way you get there. But it's totally fine to have to have grading show up there, because a grater is a process that can achieve that form objective at a certain time.
So is the thinking like grading could show up under this as well as under this?
That's right. But we will want inference to sort of figure out the other hierarchies, but maybe have the built-in hierarchy be that'll be a point of debate, actually, which one is built pure and which one is inferred.
Yeah, I mean, in simple language, the act of grading is both there are some mechanics of it, like you have to push something through something to make something break up into bits, right? And there is an objective, which is to end up with something shredded, right? So that it can be sprinkled, or so that it's smaller pieces, or what have you. So both things are true. Like all of these things should ultimately have two parents, so to speak. Why you're doing it and how you do it. I was trying to focus, specifically on the how, the mechanics, but yes to both.
Yeah. And it's this creativity, the substitution is where you have both described. Okay, great.
Great. I think that we can get everyone's perspective in this. I think that Tarini's way of thinking about it and Troy's actually both do work together. We just have to make sure that it works for like on a term-by-term basis. But that's why I think it would be really helpful to pull out some examples like grading and cutting and place them under both of these things and say like, okay, we're feeling good about this being both fractionation by objective and by some subclass of surface mechanism. And I think that's kind of the next step.
Some level down, yeah. Okay, thank you, everybody. And this is a great, neat, and important thing for us to all do groupthink together, even though it may seem a little redundant for some or others. Okay. Talk to you in 2 weeks.
Thanks, everyone.